So in this video, we want to evaluate this integral here. Partial fractions here is probably not an option. This doesn't factor the way it's written. A couple of ways to do it though. One could be a trig substitution. We could use this particular formula here. So it's the integral u prime u squared plus a squared dx. U prime means the derivative there, so that's just du over dx, which first part here transforms into this one here, du over u squared plus a squared, and that's given by 1 over a arctangent of u over a plus c. So we want to write it in this first form here. By doing that, we need to complete the square on this integral, or I should say complete the square of the expression in the denominator, this x squared minus 4x plus 7. So I'll write it over here. Let's say this is equal to, coefficient here is 1, so if I take half, if I take half of -4, that's -2, and square it, that gives me 4. Half of -4 is -2 squared, -4. So I need this 7 to be a 4 here. So we could do this. I could add 4 or subtract 4 to do that. Or I could simply say break up 7 into 4 and 3. So this would be -4 x plus 4. And I'll just put a plus 3 here. 4 and 3 is 7, so I haven't changed the problem. This is equal to the integral of dx over, and then x squared minus 4x plus 4, that's a perfect square. So I complete the square on that trinomial, and that factors into x minus 2, quantity squared. And I'm going to write 3 as the square root of 3 squared. So by letting u equal to x minus 2 and say a equal to square root of 3, I have it written in the form that I want it, so I can use the formula. So I'll say this is equal to, and then this will go over here, integral, and then if I take derivative of both sides of u, and that'd be du. The derivative of the right side will just be 1, derivative of a constant, minus 2 is 0, derivative of x will be 1. You can write that as du dx. So rewriting the integral here, I can put du up here. Du and dx are the same. In the denominator, then this would be u squared du over a squared plus a squared. Now it looks just like the formula we just looked at. So then I could just rewrite this then. The formula said that the integral of an expression in this format here would be the same thing as 1 over a and it'd be arctangent of u over a. Just so you can see the relationship between the two formulas. That's the answer, and then plus a constant of integration. And then we just fill it in. So it's 1 over a, and a is the square root of 3. And we have arctan of u over a, and u is x minus 2. A is the square root of 3. And I'll put this in parentheses here. Plus a constant. So all we did is rewrote it in terms of u and a. And then we used the given formula. We could also use a trig substitution, another way we could do this. But in this case, if they ask you to come to find the integral by completing the square, in this case we completed the square of the denominator x squared minus 4x plus 7 to get it in this format. This is your answer here. Thanks for watching. We'll see you next time.